Hello everyone, in this video I'm going to explain how to check if a given number is power of 2 or not. Check if a number is power of 2 using bitwise operators. So there are two methods, so I'm going to discuss both of them. Method 1, let us see a number which is power of 2 uh, to the power 1, 2, 2 to the power 2, that is 4, 2 to the power 3, that is 8, 2 to the power 4, that is 16. Let's convert all these in binary form. It is 1 0, it is 1 0 0, it is 1 0 0 0, it is 1 0 0 0 0. So we can notice that a pattern in all of these numbers which are power of 2, that is there is only one sad bit in them. So we can use this property to find out if a given number is power of 2 or not. So we are going to count number of ones in its binary representation, and if number of ones is 1, then we can say surely that the given number is power of 2. So let's try to implement this. Now here I am going to make a function check, which is going to check if the given number is power of 2 or not. So it is going to return a bool type value, which I am going to take in a bool type variable I'm going to name answer. So if this answer is true, then I am going to see out it is power of 2. Otherwise the number is not power of 2. Now let us complete this check function. It is going to be bool type, so its return type will be bool. Its name is check, and it is going to take an integer. So now a integer number can be maximum 32 bit long. So running a for loop for 32 bits from 0 to I less than 32 I plus plus. So I'm going to here count number of set bits in that numbers. So for that purpose I am declaring a variable here, count, initializing it with 0. Now if for particular bit, that is if n bitwise and 1 left shift y position I. So first initially I will be 0, so we'll check 0th bit, then I will become 1, so we'll check first bit, and if that bit is set, then this if will become a non-zero value and this if will get executed, and if that particular bit is 0, then the result of this end bitwise and 1 left shift I will be 0, so this if will not get executed. So if it get executed means that the result and bitwise and 1 left shift by I is non-zero, then we'll increase our count as it is a sad bit, particular bit is a sad bit. So I'm going to increase count. Now after checking all 32 bits, if this count remains 1, means that there is only one sad bit, count is equal to 1, then I'm going to return true. Otherwise I'm going to return false. Now let's check. I'm providing here integer 2. Now let's check by running it. Yes, it is showing that 2 is power of 2. Now let's check for 3. So it's showing that 3 is not power of 2. Checking for 4. Yes, it's showing it is power of 2. Checking 16. Also showing it is power of 2. Now checking for 17. It is showing that 17 is not a power of 2. So this code is working fine. Now let us see another method. Let us see method 2. So method 2, previous method was taking log n time. Because a number n can have maximum log n bits, so to scan the whole number, to scan all the bits, we have to run loop log n times. Now in this method we are going to perform the same function in constant time, that is big O of 1. So now let's see this method. To understand this, I'm showing through an example. Now if I write a number, let's say 10, and its binary representation, that is 1010. So if I subtract 1 from 10, then how its bits are going to change? So for 9, let's write its binary representation, that is 1001. So how this bit representation differ from this bit representation? So there is change here and here. This got flipped, and this bit also got flipped. Now let us try to find out same relation with other numbers, 12 and 11. 12's bitwise representation is 1100, and 11's is 1011. Now we can find out that here the change is in 3 bits, these 3 bits, and these are also flipped. And let's see with another number, that is 15 and 14. 15's bitwise representation is 1111, and 14's 1110. So there is flipping only in 0th bit here. So we can find out that there is some relation. So when we traverse from right side, and when we reach a set bit, up till then all the bits get reversed from the number if we subtract 1 from it. So when we try to traverse this from right hand side, we reach here 1. So all the bits from right hand side till this 1 will get flipped. So this 0 get flipped to 1, and 1 got flipped to 0. Now in this case we got 1 here, and so all the bits from right hand side till this 1 will get flipped. Similarly in this case we find the set bit in the 0th place, so only 1 bit got flipped. Now let's check the same for one another pair, that is 16 and 17. Its representation is 10001, and its representation is 1 1 2 3 4. Now we can find that here we found 1 at 0th 0th bit, and so it got flipped, only 1 bit got flipped to 0, that when this one got flipped to 0. So we can use this property to find out if whether a given number is power of 2 or not. Let's see how. So let us try it with 16, as it is a power of 2. 60's binary representation is 10000. So if I subtract 1 from it, then it becomes 15. Then all the bits will get flipped till we find 1 from right hand side. So these all bits will get flipped. This 0 will become 1, 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 and this 1 will become 0. So if I try to do bitwise AND operation between these two numbers, and result comes out to be 0, see, and 0 is there in front of this one, there is 0 in front of this one, so it these result of these AND of these two bit will be 0, result of these two bits and operation, bitwise AND operation will be 0, and bitwise AND operation between these two bit 0 and 1 will also be 0, and these two bits are also different, so here AND operation will be 0, so the whole number will become 0. So this is the case only when the given number is a power of 2. So now let's see how we can do that. We have to do a and a minus 1. If this value comes out to be 0, it means that a is a number which is power of 2. If it comes other than that, if it comes a non-zero number, it means that it is not a power of 2. Let's try to find out with this. As 10 is not a power of 2, if we try to do AND operation between 10 and 9, so this will become 0, this will become 0, and this will become 0, and this will become 1. So if the number is not power of 2, then the result will be always a non-zero number. So let's try to implement the same. This is the code that I used for checking method 1. I will use the same code for method 2. I have to change only this check function. So here I am going to do if n bitwise AND with n minus 1 comes out to be 0, it means that n is a number which is power of 2, so I will return true, otherwise I will return false. Now let's try to run it. Initially I am checking for 17. Yes, it is showing 17 is not power of 2. Checking for 16, is it power of 2? Yes, it is showing 16 is power of 2. Now let's check for 8. Yes, it is showing 8 is power of 2. Now let's check for 6. Yes, it is showing 6 is not power of 2. Hope you understood the concept of finding that a number is power of 2 or not. Thank you.